Good morning, students. Welcome to Mathematics 7, Quarter 4, Week 5. By the way, my name is Roland J. Viola, your subject teacher in mathematics. With our topic this morning, let's have first our objectives. So our objectives are A. Define measure of variability and other related terms. B. Illustrate the measure of variability such as range, average, deviation, variance, standard deviation of statistical data. And C. Calculates the measure of variability of group and ungrouped data. And D. Interpret the data. Measure of variability, range, interquartile range, variance, and standard deviation. A measure of variability is a summary statistic that represents the amount of dispersion in a data set. How spread out are the data values? While a measure of central tendency describes the typical value, measure of variability defines how far away the data points tend to fall from the center. We talk about variability in the context of a distribution of values. A low dispersion indicates that the data points tend to be clustered tightly around the center. High dispersion signifies that they tend to fall further away. In statistics, variability, dispersion, and spread are synonyms that denote the width of the distribution. Just as there are multiple measures of central tendency, there are several measures of variability. In this topic, you will learn why understanding the variability of your data is critical. Then explore the most common measure of variability, the range, interquartile range, variance, and standard deviation. This will help you determine which one is best for your data. So the two plots below shows the different graphically for distribution with the same mean but more and less dispersion. The panel on the left shows a distribution that is tightly clustered around the average, while the distribution in the right panel is more spread out. So this is the graph uh, wherein it shows there the difference between the two deviation. Why understanding variability is important. Let us take a step back and first get a handle on why understanding variability is so essential. Analysts frequently use the mean to summarize the center of a population or a process. While the mean is relevant, people often react to variability even more. However, when the variability is higher, the data points are more dissimilar and extreme values become more likely. Consequently, understanding variability helps you grasp the likelihood of unusual events. In some situations, extreme values can cause problems. Have you ever seen a weather report where the meteorologists show extreme heat and drought in one area and flooding in another? It would be nice to average those together. Frequently, we will feel discomfort at the extremes more than the mean. Understanding that variability around the mean provides critical information. Variability is everywhere. Your commute time to work varies a bit every day. When you order a favorite dish at a restaurant repeatedly, it is not the same each time. The parts that sum up an assembly line might appear to be identical, but they have subtly different lengths and widths. These are all examples of real-life variability. Some degree of variation is unavoidable. However, too much inconsistency can cause problems. If your morning commute takes much longer than the mean travel time, you will be late for work. If the restaurant dish is much different than how it eats usually, you might not like it at all. And if my manufactured part is too much out of spec, it will not function as intended. Some variation is inevitable, but problems occur at the extremes. Distribution with greater variability produce observation with unusual large and small values more frequently than distribution with less variability. Example of different amounts of variability. Let us look at two hypothetical pizza restaurants. They both advertise a mean delivery time of 20 minutes, where we are ravenous. They both sounds equally good. However, this equivalence can be deceptive. To determine the restaurant that you should order from when you are hungry, we need to analyze their variability. Suppose we study their delivery time, calculate the variability for each place, and determine that their variabilities are different. So we have computed the standard deviation for both restaurants, which is a measure that we will come back to later in this post. How significant is this difference in getting pizza to their customer promptly? So the graph below show the distribution of delivery times and provide the answer. So the restaurant with more variable delivery times has the broader distribution curve. I have used the same scales in both graphs so you can visually compare the two distribution. In these graphs, we consider a 30-minute wait for longer to be unacceptable. We are hungry after all. The shaded area in each chart represent the proportion of delivery times that, that surpass 30 minutes. Nearly 16% of the deliveries from the high variability restaurant exceeded 30 minutes. On the other hand, only 2% of the deliveries take too long with the low variability restaurant. They both have an average delivery time of 20 minutes, but I know where I would place my order when I am hungry. As this example shows, the central tendency does not provide complete information. We also need to understand the variability around the middle of the distribution to get the full picture. Range. Let us start with the range because it is the most straightforward measure of variability to calculate, the simplest to understand. The range of a dataset is the difference between the largest and smallest values in the dataset. For example, in the two datasets below, dataset 1 has a range of 20 to 38 is equals to 18, while dataset 2 has a range of 11 minus 52 is equals to 41. So dataset 2 has a broader range and hence more variability than dataset 1. So while the range is easy to understand, it is based on only the two most extreme values in the dataset, which makes it very susceptible to outliers. If one of those numbers is unusually high or low, it affects the entire range even if it is typical. Additionally, the size of the dataset affects the range. In general, you are less likely to observe extreme values. However, as you increase the sample size, you have more opportunities to obtain these extreme values. Consequently, when you draw random samples from the same population, the range tends to increase as the sample size increases. Consequently, use the range to compare variability only when two sample sizes are similar. The interquartile range or IQR and other percentile. The interquartile range is the middle half of the data. To visualize it, think about the median values that splits the data set in half. Similarly, you can divide the data into quarters. Statistician refers to these quarters as quartiles and denote them from low to high as Q1, Q2, and Q3. The lowest quartile rather is Q1 contains the quarter of the dataset within the smallest values. The upper quartile Q4 contains the quarter of the dataset with the highest values. The interquartile range is the middle half of the dataset is in between the upper and the lower quartiles. In other words, the interquartile range includes the 50% of data points that fall between Q1 and Q3. The IQR is the red area in the graph below. So the interquartile range is a robust measure of variability is in a similar manner that the median is a robust measure of central tendency. Neither measure is influenced dramatically by outliers because they do not depend on every value. Additionally, the interquartile range is excellent for skewed distribution just like the median. As you will learn, when you have a normal distribution, the standard deviation tells you the percentage of observation that fall specific distances from the mean. However, this does not work for skewed distribution and the IQR is great alternative. I have divided the dataset below into quartiles. The interquartile range extends from the low end of Q2 to the upper limit of Q3. For this dataset, the range is 21 minus 39. Using other percentiles. When you have a skew distribution, I find that reporting the median with the interquartile range is a particularly good combination. The interquartile range is equivalent to the region between the 75th and 25th percentile. You can also use the other percentiles to determine the spread of different proportions. For example, the range between the 97.5th percentile and the 2.5th percentile covers 95% of the data. The broader this ranges, the higher the variability in your dataset. Variance. Variance is the average square difference of the values from the mean. Unlike the previous measure of variability, the variance includes all values in the calculation by comparing each value to the mean. To calculate this statistic, you can calculate a set of squared differences between the data points and the mean. Sum them and then divide by the number of observations. Hence, it is the average square difference. There are two formulas for the variance depending on whether you are calculating the variance for the entire population or using a sample to estimate the population variance. The equations are below, and then I work through an example in a table to help bring it to life. Population variance. The formula for the variance of the entire population is the following. In the equation, standard deviation squared in the population parameter of the variance. Use the parameter for the population matter and n is the number of data points which should be included in the entire population. This is the formula as you can see in your screen. That is the formula for the variance. Sample variance. So use the sample to estimate sample variance. So use a sample to estimate the variance. For a population, use the following formula. Using the previous equation with the sample data tends to underestimate the variability because it is usually impossible to measure an entire population. Statisticians use the equation for sample variances much more frequently. In the equation, S squared is the sample variance and M is the sample mean. N minus 1 is the denominator correct for the tendency of a sample to underestimate the population variance. Example of calculating the variance. I will work through an example using the formula for a sample on a dataset with 17 observations in the data table. The number in parentheses represent the corresponding table column number. The procedure involves for taking each observation. 1. Subtracting the sample mean. 2. To calculate the difference. 3. And squaring the difference. And 4. Then I sum the square difference at the bottom of the table. Finally, I take the sum and divide by 16 because I am using the sample variance equation with 17 observations. 17 minus 1 is equal to 16. The variance for the dataset is 200 watt. Because the calculation used the square difference. says the variance is in squared units rather than original units of the dataset. While higher values of the variance indicate greater variability, there is no intuitive interpretation for specific values. Despite this implementation, various statistical tests use the variance in their calculation. Standard deviation. The standard deviation is the standard deviation of a typical difference between each data point and the mean. When the values in a dataset are grouped closer together, you have a smaller standard deviation. On the other hand, when the values are spread out more, the standard deviation is larger because the standard distance is greater. Conveniently, the standard deviation uses the original units of the data, which make interpretation easier. Consequently, the standard deviation is the most widely used measure of variability. For example, in the pizza delivery example, a standard deviation of 5 indicates that the typical delivery time is plus or minus 5 minutes from the mean. It is often reported along with the mean 20 minutes, with a standard deviation of 5. The standard deviation is just the square root of the variance. Recall that the variance is in squared units, hence, then square root returns the value to natural units. The symbol for the standard deviation as a population parameter is that, while S represents it as a sample estimate. To calculate the standard deviation, calculate the variance as shown above, and then take the square root of it, you have the standard deviation. So in the variance section, we calculate the variance of 201 in the table. So therefore, the standard deviation of that data set is 14.177. Range of group data. The range is the simplest measure of variability. The range of the upper frequency The range of a frequency distribution is simple that the difference between the upper class boundary of the top interval and the lower class boundary of the bottom interval. Okay. So the upper so solution so from the data set given. So upper class limit of the highest interval is equals to 50. Upper class boundary of the highest interval so is equals to 50 plus 0.5 is equals to 50.5. Lower class boundary of the lowest interval is equals to 21. Lower class boundary of the lowest interval is equals to 21 minus 0.5 is equals to 20.5. Range, upper class boundary of the highest interval minus lower class boundary of the lowest interval. So 50.5 minus 20.5 is equals to 30. Therefore, the range of the given dataset is 30. Variance of group data. Variance is the mean of the square of the deviation from the mean of a frequency distribution. For large quantities, the variance is computed using frequency and midpoint value for each interval, the deviation and its square, and the product of the square frequency and the square deviation. To find the variance of group data, use the formula here. Use that formula where f is equal to plus frequency x is equal to class mark and x with the dash above is equal to class mean, and summation of f is equal to total or number of frequency. In calculating the variance, do the following step. Number 1. Prepare a frequency distribution with appropriate class intervals and with the corresponding frequency. And 2. Get the midpoint x of each class interval. Number 3. Multiply frequency and the midpoint of each interval to get the f of x, and add f of x of each interval to get the summation of f of x. Compute the mean using the formula mean is equals to summation of f of x divided by summation of f. Calculate the deviation. So x minus mean is by subtracting the mean from each midpoint. Square the deviation of each interval to get this. Multiply the frequency and x minus mean squared. Found the sum of each product to get the summation of f parentheses or multiplied to x minus mean squared. Calculate the variance using the formula. Okay, so for example, find the variance of the given data set. So we have the table. So first you need to do the steps. No, these are the 9 steps in calculating the variance. So after you have the table, as you can see on your screen, there is a table. So you have already the values that you needed to substitute to your formula. So just if you get already those values, then just simply substitute it to the formula. So therefore, in this given example or data, our variance is 40.24. Standard Standard deviation is considered the best indicator of the degree of dispersion among the measure of variability because it represents an average variability of the distribution. Given the data of set, given the set of data rather, the smaller the range, the smaller the standard deviation, the less spread is the distribution. To get the value of the distribution, get the square root of the variance. So in here we have already the given formula where s is equals to the square root of variance squared square root of variance squared. So just simply substitute this uh, to the values. Just simply substitute the values of it, and then in here the lower part of your screen we have our s is equals to a square root of 40.24, and then the square root of that is equals to 6.34. I think that's all for today, class. Thank you for listening and God bless.